So first of all, let's define what a half-life is. Half-life. A lot of times you'll see it with a lowercase t, 1/2. That's kind of our symbol for half-life. Okay? And we're talking about decay, breakdown of our nucleus, okay, in order to become more stable. So we've had an alpha decay and a beta decay, and there's other types of decay that you saw on the worksheet there. So definition, half-life is the time, okay, half-life, it's a time, the time it takes for half of a substance to decay. The time it takes for half the substance to decay. It could be as fast as a millisecond. It could be thousands of years, like uranium-235 is around 107,000 years for it to break down, so it stays around for a while, okay, with that. It could be a couple of days, a couple of hours. It can vary between substances. So it's the time it takes for half the substance to decay. So example, let's say that we have a half-life of 6 hours. Let's say we have a half-life of 6 hours, and we have 200 grams of sample X. Maybe X is radioactive of some sort. Okay, so 200 grams of sample X. Okay, so after 6 hours, how much of our sample do we have left after 6 hours? After it decays, how much do we have left? 100 grams. Okay, so the half-life is the time it takes for half the substance to decay. Half-life is the time it takes for half the substance to decay. So after 6 hours, half of the substance has broken down. Okay, and so now we get 100 grams. If we go through another 6 hours, so now we have a total of 12 hours, how much mass do we have from our sample? 50 grams. Okay, and then you keep doing that, all right? 18 hours, we would have 25 grams. Okay, get the concept? Okay, so the half-life is how much time it takes for half the substance to decay. So after that time, we have a certain mass left. We have to focus on that mass that's left when it breaks down again. We don't go back up to the initial amount because that's all gone. Okay, got the concept? All right, now look at question number 1 on your worksheet. I'm going to walk you through 2 ways that you can do the math. I'll show you the conceptual way, and then I'll show you the mathematical way you could do it. Go. Okay, it says the half-life, so number 1, it says the half-life of cesium-137 is 30.2 years. So I'm going to write down my given. My half-life equals 30.2 years. We have an initial mass of 1 kilogram. So we're going to change that to 1,000 grams to make it easier for us. We don't want to do any conversion stuff yet because we haven't talked about that. Okay, so we'll do 1,000 grams. Okay, after 150 years, wow, that's a long time. After 150 years, they want to know how much mass is left. So of the 1,000 grams, after 150 years, how much mass is left? Okay. All right, so we have a half-life, we have initial mass, and then we have a after total amount of time. Okay. All your questions that we're going to look at are very similar to this one. From this, we can do a lot of different other math. We can look at the initial mass. We can try to figure out what the half-life is. I don't want to spend a lot of time doing that. You do that in math class, okay? I'm going to focus on just questions like number 1, all right? So the first thing that we have to do is to identify how many half-lives does a substance go through? How many times does it break down? Okay? So the first thing that you want to figure out is how many half-lives or how many times does my substance break down? Okay, again, first thing that you want to do is figure out how many half-lives or how many times it breaks down. I'm going to do that by taking my total time and dividing it by my half-life. I'm going to take my total time divided by my half-life. So in this problem, we have 151 years, and my half-life is 30.2 years. Okay? All right, so if you do that math, how many times, how many divisions, how many half-lives does this substance break down? 5 times, very good. So it breaks down 5 times. Okay? It's important to understand that because, like an example we just talked about with the definition, you know, we break down, break down, break down, break down. Okay, so now is the easy part. There's 1 or 2 ways that you could do this. Okay, if you're not very math savvy, you don't want to look at equations and so forth, here's what you're going to do. You're going to take 1,000 on your calculator, type in 1,000 on your calculator. Okay. And since it's a half-life, we're going to divide by 2. Okay, since it's a half-life, we're going to divide by 2. But we're going to divide by 2 5 times because it breaks down 5 times. So on your calculator, you're going to put 1,000 divided by 2, divided by 2, divided by 2, divided by 2, divided by 2. Okay, you're going to divide by 2 5 times. All right, and you should get what value? 31.25 grams. Very good. Okay. Everybody got that part? All right, if you're more math savvy, I know there's a couple different ways you can do this. This is the way I like it. I'm going to put 1,000 grams on top. So my beginning mass goes on top. And then I'm going to divide by 2, because that's my half-life, okay? And then to the exponent x, And that exponent is the number of half-lives. Okay, so I have 5 half-lives, right? So this is 1,000 divided by 2 to the 5th power. Okay, 1,000 divided by 2 to the 5th power. And you're going to get the same answer as 31.25. I say that because I like the math work here, because sometimes on these answers up here, you might get a half-life of or you might get an answer here of 15. So you have to divide this by 2 15 times. Okay, and then more power to you, just don't lose count. Okay? All right. Got the idea? Okay, now you're going to do number 6, and you're going to do number 9. Number 6 and number 9. Again, we're going to change the 1 kilogram to 1,000 grams. Okay, so number 6 and number 9, both of them, change the kilogram to 1,000 grams. Okay? All right, ponder those two, see what we do. And then I have a plethora of extra if we need it. If not, then you're good to go for the test tomorrow. Okay?
Will we ever get like a decimal for where the number 5 is? Like that number?
Try not to. Try to get a whole number. Yeah. The question was, do we ever get like a decimal for how many times it breaks down? most often not, we try to give you whole values for that. Not that you can't do the math work, we can't do it this way, but you can do it this way still. Okay, so kind of keep that in mind. All right, 6 and 9 on that worksheet. Yeah, so this is just 1,000 grams. Yep, 1,000 grams. I think, I don't know if you can see it from here. There's a glare on it. It says 1,000. Okay, gotcha. Yes, we haven't gotten to the unit conversion stuff yet, so we'll just make it simple for us. Again, with these problems, if you look on that worksheet, we can figure out the half-life or something. We can figure out what the initial mass was back in the day. That's a whole new math lesson, and we don't have time for that. So if you can do these types of problems, these are your basic common problems that you see on ACT tests and stuff like that, and on the exam, and on the test tomorrow. So we're going to focus on just problems like 1, 6, and 9. Okay. Don't forget to show the math work. Don't forget to label your answers. All right, it's not 31.25. That's a number. 31.25 grams would be our answer. All right, so number 6, take a look at number 6. We have 14.3 days is the half-life. We have initial mass of 1,000 grams and total time of 100.1 days. So first thing I have to do is figure out how many times we have, how many half-lives it goes through, how many times it breaks down. So I'm taking my total time divided by my half-lives. I get 7. So I can either do it the mathematical way, 1,000 divided by 2 to the 7th power. I get 7.82 grams. or 1,000 divided by 2, 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 7 times, and you get the same answer. Okay? As far as rounding goes, until we get to sig figs in the next unit, 1 or 2 decimals is sufficient. We don't want just a whole number. That's not good a science value. Okay, so you want at least 1 decimal, if not 2 decimals, for our answers.
Well, for your 7, so you want us to on that.
We're at?
Like the 101
Yep.
by 14.3. You want us to like round to the.
Well, this should be a whole number 7. Right? Double check. Okay. We're good?
Wait, wasn't it round to 7.81 instead of 7.82? Because it ends up being 7.8165.
Right. Thank you, thank you. All right, good teamwork. All right. There you go. What's that?
Why do we only round to 100 spots?
Well, right now, that's what I'm telling you to do. But when we get to what we call significant figures in the next unit, then you won't need me to tell you to round. You'll be able to know what to do because there's certain rules when we do math and science of how to do the answer. Okay. So like in math class, where like with this problem here, if you get 7 point and then you get like six decimals, right? How do you do rounding? There is a rule for that in science. They probably don't teach you that in math class, but there's a rule for that in science only when you use measurements. Numbers, it doesn't, I don't think it applies with numbers, but with measurements, you have to use a certain rule with what we call sig figs or significant figures, okay? And that'll be in the next unit, okay? And so then from that point on, whatever math that we do, you'll be able to know what the answer is going to be, how many decimals and that sort of thing. Okay, good question. Okay, look at number 9. You got a question? You don't get number 9?
I'm just trying to do like seconds, not minutes.
Can I give you a few minutes here to work on number 9? Again, this is going to be 1,000 grams. So keep it in mass, keep it in grams. So we have a half-life, that's 1 minute. Every minute the substance decays half of the amount. We have 1,000 grams that we started with. How much will remain after a half an hour? 1 minute, half an hour. How many minutes are in a half an hour? 30.
So it's your total time divided by your half-life.
Mm-hmm.
So like our total time is, wait,
Half an hour.
I don't know where I got an hour from. Probably didn't. Okay, I get it now.
You good?
Yeah.
Okay. Nice job. Nice job. What you got?
I don't have a calculator with me right now, but I know exactly what to do.
Ooh, okay. Make sure you have a calculator for tomorrow's test, though, okay? All right. Hey, folks, FYI, on quiz and test, you cannot use your phone as a calculator on quiz and test. You have to have a calculator for class. All right? So tomorrow, you do not want to forget a calculator on a test day. All right, so please, if you have one that has to be, batteries has to be recharged, make sure they're recharged well, or have a backup. Okay? But don't come to me tomorrow and say, I don't have a calculator, can I borrow yours? I'm not going to give you mine. Okay, number 9. What's the half-life? 1 minute. Okay, what's our initial mass? 1,000 grams. And then what's my total time? 30 minutes. Okay, so how many times is this substance going to break down? 30 times. So you're going to have 1,000 divided by 2 to the 30th power, or 1,000 divided by 2, 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 30 times. Okay? Either way, you need to be able to solve an answer for that. And this one you get, it's a very, very small amount. 9 point something, what is it? 9.31 times 10. -7, I think, grams. Okay? Now, on your calculator, you might see 9.3 capital E -7. Okay? That capital E is your 10, is your times 10. The -7 is your exponent. Okay, hopefully they taught you that in math class. If not, I'll teach you that when we do sig figs.
Which notation would you rather us use?
For your answers, I want to see this. Okay, but if you have E, I won't take off for it, but I want to see this because that's what we have in common in science. Okay. Okay, you want to do one more, or you think you got the idea? If you're confident, one more? Let's do one more. Okay, if you're confident with this, then go ahead and work on your study guide. Okay, here's actinium. Actinium. This is a different worksheet. Everything else on that worksheet is every extra type of math, so we want to keep it all the same for you. So here's an extra one. Actinium-226 has a half-life of 29 hours. We have 100 milligrams of actinium, so not very much. It's going to disintegrate over a period of 58 hours. How much is left? 58 hours. Yeah, this is 100 milligrams. 100 milligrams. Again, if you're confident with the half-life problems, right, that's our last lesson, to go ahead and work on your study guide. I sent you the answers. I emailed the answers about an hour ago. On the test tomorrow, there are 24 multiple guess questions, and there are 16 free response questions. Now, along the way, I gave you about 8 of these free response questions during class, during our lessons. You already have one of the essays. That's the last question on the free response. Okay? The multiple guess questions are level 1, level 2 questions. So there's a couple questions you got to really think about, but a lot of the questions are pretty straightforward. Okay? This might look like a lot of questions, but that helps you in the sense that if you don't have very many questions, you miss a couple, your grade drops pretty quick, right? So it's better to have more points than not very many points. The other thing on this is that, in my mind, as we've gone through this material and I've helped you out with a study guide, I've helped you out with a lot of stuff during class, I've been giving you questions along the way, you should be able to get through this fairly quickly. If it takes you a long time to do the multiple guess questions, then that tells me that you haven't stayed up with studying for the test. Maybe you wait until yesterday and today to kind of prepare for it. Can't do that for our chemistry classes. Okay, you cannot procrastinate. There's too much vocabulary, there's too much concepts that's new to you to keep track of the night before. Okay? All right, I'll give you a couple more minutes for number 2, and then I'll kind of walk you through it, and we can keep doing more and more and more if you need to. I'm okay with that. Again, if not, you should be working on your study guide. Oh, we got 3 minutes. That was a fast hour. We have 3 minutes. Wow.